One of me, Mitigate Godambara. Hello friends, it's good to see you.
What we see here today is a $10.5 million installation that is unique in the world. In Australia, we led the way in adaptation into our unique conditions, our mining industry, to be one of the most safest industries in the world. What excites me here is this equipment with what we have back up at near with the propagation tube and the reactor is allowing that science to continue.
There's a lot of expensive kit on this particular site, allowing for a broad range of methane concentrations to be studied. When the ignition is achieved, we have to close 200 high-speed pressure transmitters and photodiodes capable of performing 150,000 measurements per second, which equates to 250 gigabytes of data per trial. That's quite significant. That should keep Jafar and his team busy for quite some time, I would have thought. But they're all excited, they're all ready to go.
Whenever you're talking about methane explosions, safety issues related to methane, or even methane abatement, everything is scale dependent. So you've got to be able to collect reliable data at different scales, and from those scale up rules, then you'll be able to design any system. So that's why we're here.
The safe abatement of methane in ventilation air from underground coal mines is an extremely important area of research and development for the black coal industry. Ventilation in air methane, or VAM, accounts for 60% of emissions from underground coal mines. The existence of commercially available abatement technology leads some to the view that with this technology there is already a readily available emissions reduction opportunity. However, these technologies come with additional hazards. We're adding a potential ignition source to operating mines. Their deployment at an operating coal mine may introduce these hazards, and such as potentially catastrophic flashback explosions that cannot be mitigated by using existing mine safety protocols that may exist. The Australian coal industry operates at some of the highest safety standard levels in the world, and as a result, VAM abatement will not be deployed unless it is demonstrated beyond doubt that it can be carried out without the overall risk to the operations. This project is central to the industry's efforts to develop a safe means for VAM abatement. As the actual abatement technology is available, the project quite rightly focused on connecting that technology through ductwork to the mine ventilation system. To progress this research, a comprehensive and rigorous scientific program has been completed, among many other things examining the fundamentals of methane ignition and flame propagation. A variety of mitigation strategies have been trialled using the detonation tube at the University of Newcastle, such as rapid acting isolation valves and flame arresters. These mitigation strategies will now be tested here on a larger scale using this facility at TestSafe. Successful completion of this project will by no means provide a blueprint for every underground coal mine. There will always be local conditions specific to each site to be taken into account. However, the excellent work being undertaken will provide valuable guidance to the issues to be addressed and the range of options available at any mine considering VAM abatement. The Australian coal industry is pleased to be associated with this work and looks forward to its successful completion. As I mentioned previously, the recently announced 10-year continuation of Coal 21 sees a further $250 million available from industry for research and demonstration in these areas. So on that note, I would like to declare this facility open and again thank Alan for the invitation to be here today and what is a great facility for the future. Thank you.